Okay guys, so today we're going to talk about endothermic and exothermic reactions. What we're going to talk about is, first we're going to go over the definition. We're going to go over what you see in lab observations, how to identify endo and exo in a lab, identifying which graph is which, and we're also going to go over how to identify the sign of delta H. So first we're going to start with the definition of each. Endothermic reaction is a reaction in which the system absorbs energy in the form of heat. And exothermic is a reaction in which the system releases energy in the form of heat. Let's start with lab observations. Okay, so in this lab, we have H2O plus KCl yields HCl plus KOH. Now, this is going to be an endothermic reaction because we're breaking apart the H2O and we're breaking apart the KCl and then forming new bonds. So, breaking bonds is going to be endothermic. Okay, down here we have carbon solid and oxygen gas, as you can see I highlighted here, all forming CO2 gas. We've got two individual things coming together, so forming bonds is an exothermic reaction. Also in lab, endothermic, since it's breaking bonds, energy is being absorbed which is going to feel cold to us. And in this particular lab, the more KCl you add, the colder it gets. In this reaction, the carbon solid and the oxygen gas producing CO2, when you are forming bonds, we are releasing energy. And when you release energy, it's going to feel hot to us. Okay, so next we're going to look at graphs. The graphs, as they are pretty cut and dry. This graph here is an exothermic graph. We have the starting energy point here. It's going to get over the activation energy hump here, and it's going to end down here. Since this is a release of energy, it's going to be exothermic. So an exothermic graph, the bottom energy source is always going, the ending energy source, is always going to be below the starting. In an endothermic graph, it's the opposite. So the starting point is here. It has a high activation energy, and the ending point is higher than the start. Since this is absorbing energy, it will be endothermic. And same with the exothermic graph, it's going to always start low, end high. Now we're going to move on to identifying the signs of delta H. Okay, so when it comes to delta H, a positive delta H is always endothermic, and a negative delta H is always exothermic. Our first example is going to be H2 gas plus 1/2 O2 gas yields H2O. In this example, we're taking two substances and forming one. So this is going to be a formation of bonds, which equals exothermic. And if it's exothermic, the delta H sign is going to be negative. In this reaction, it's a little bit tricky, but we've got solid carbon, solid sulfur, creating a CS2 liquid. This is our indicator here that it's going to be endothermic because we've got two solids forming a liquid. So we are breaking bonds in this reaction, which is going to be endothermic. And if we look back at the top one more time, endothermic has a positive delta H. So the sign of this is going to be positive. Okay. Alrighty. So now that we've gone over lab observations, identifying graphs, and how to tell what the sign of delta H is going to be, now would be a good time to pause the video and try this example on your own and identify if this is going to be a negative or a positive number. Okay, so after you have gone through, you should find that this is going to be, a negative delta H. Now would be a good time to pause the video and see if you can identify which graph is endothermic and which graph is exothermic. Okay, you should have found that this graph here is going to be endo, and this graph here is going to be exothermic. And one last example is going to be our lab example here. And now would be a good time to pause the video and see if this is going to be an endo reaction or an exo reaction. Okay, so after you have gone through and checked the signs of each of these, this is a liquid, solid, and a gas. You should find that this reaction is going to be exothermic because we broke up the liquid, the solid, and it produced a gas. And that's the overview of endothermic versus exothermic. I hope this helped.